Okay, so we this time choose a medium question. Just multiply the string, probably. So again, we do this in a mock interview format. So I'm not going to solve this problem in the code. Instead, we have terminal. So just write it. New folder like multiply string. Okay, so we're here. This is the number 43. Multi string C++. Okay, so this is the question number 43. Okay, so for this question we are given two non-negative int, which is number 1 and number 2. Okay, so they are represented as string. So string, and we want to have the product of the number 1, number 2. Okay, so the product also represented as a string. Okay. So that's the question. So test cases. So input, if number 1 is equal to 2, number 2 is equal to 3, the output should be 6. Okay, so that's the first test case, and we can have other test cases. We can have input, we have number 1 is equal to 1, 2, 3, 4, 5, 6. Number 2 is equal to 34, or maybe 98. So output, I don't know the output, so we open the calculator. 1, 2, 3, 4, 5, 6 times 98. 1, 2. Okay. So the output should be also a string 1209 8688. Okay. So the third one, input number 1 is equal to 1, 2, 3. Number 2 is equal to 4, 5, 6, probably. And this time the output, I know this will be 5, right? So some special cases, input is equal to 1. All right, so number 2 is equal to, okay, whatever. So the output should be the same, right? So I just need to add the number 1 here. Oops. And some other input number 1 is equal to 0. Number 2 is equal to 2233. Output should be 0. Okay. So I think that's all the test cases that we can come up with. So let's just come to the constraints. So So first we define the number 1 and is smaller than 1000 or 10,000 maybe. Your algorithm should be long enough to handle those. So also digit only, and also non-negative, and also, well, let's have a look. Oh yeah, so number 1 and number 2 does not have any leading 0. All right, cool. And also one more thing that we can do is we can have, what do we also have? We can have, I don't think there is more constraint for this one. So time complexity. So for this one, we just assume we use the basic method, just the basic school multiplication, not any other advanced ones like recursion or the Kosoba. So we can do a little bit analysis for Kosoba later. So this one, let's assume we have 2 integers with the length of n. So n and number 2 is n digit. Okay, so this time the time complexity will be, so for each of the digits we're going to perform a single operation which take constant time. So we have n digit in the first number, n digit in the second number, and they are going to make a square. Right, so okay. So this will take n times n, which is n square. So the time complexity for the basic method should be log n, n square. Yep, I assume you get it, because sometimes what I do is I draw a little bit diagram when analysis the time complexity of a algorithm. This is a very basic method. We don't need recursion, we don't need other ones, so we probably just do it here. What we can also do is we can do Kosoba multiplication, which is a little bit easier in terms of the time, not the implementation. So we have more faster solutions. So for example, we have the number 1 is equal to x1. Let's say just number 1 is equal to x. Better s is equal to x1 plus x0. So the x0 is the other, like the other part. Well, the first part is x1. So x1 we need to times a base to the power of n. So the other number should be y1 times the base of n to the power of n, and then y0. So this time x times y is equal to x1 y1 plus, sorry, we need to times the base to the power of 2n as well, plus, so we cross the x1 y0 and y1 x0, so that should be x1 times y0 plus x0 plus times y1, and they times the base to the power of n, and then plus the x0 times y0. So that's the normal expression. So we have so that's the method that we're going to implement this time. So you see, this way we do basically n square operations to complete those formula. We can also do a little bit easier, which is the Kasuba multiplication. So we calculate x0 times y0. We calculate the x1 times y1. And we also calculate the x1 plus x0. And we also calculate the y1 plus y0. Because addition is easier than the multiplication. Again, we are saying the basic method, right? So this time we can have this little formula, being representative by the other parts of the, let's say, this one equals 0 is this one. So Z3 and Z2 is this one, and we calculate Z3 is equal to the multiplication of these two formula. Okay, so this time we don't need to calculate this one. This way we don't need to calculate the x1 times the y0 plus x0 times y1, which is the most complete part. We can so this time this formula is equal to J3 minus J2 minus J1. Sorry, minus J0. We don't have J1. Okay. So this is Kasuba multiplication. This is the idea of it. So this time we can simplify this formula to the following formula. So x times y is equal to z2 times the base to the power of 2n and plus j3 minus j2 minus j0 times the base to the power of n, and we plus the last one, z0. Okay. So this time we don't need to calculate this part of the formula, which is z1, if we use this representative method. So so for this time we are saving a way of the, you see, 1, 2, 3. Well, traditionally we get 1, 2, 3, 4 because 2 times 2 is 4, right? So this time we are saving 1. So we are not actually saving literally 1, we are saving log the method of 3, base 2 and 3. So we represent this way. So this time the type complexity will be theta to the n to the power of this. So I assume you get me. So we actually going to implement the basic method. Okay, so again we're using C++. Let's, because we have string, I'll see out line. So these are the most fundamental things to include. We might add more. So string, this time we're going to return a string, and we just say basic multiplication. I just sure I get this spelling correct. So string number 1 and string number 2. Okay, so we have to do multiplication, we need to do, well, let's do a little bit work here. A1, just digit, and we have digit here. Okay, so first we need to get the length of those. Number 1 length is equal to number 1 dot size. Okay, so we're going to initialize the result, which is we're going to return the result finally. So we're using a constructor of the string. Well, maybe I do this correct, I think, probably. Well, let's verify it later when we run the program. So number 1th length plus number 2th length, and initialize every digit with 0, which is a character. Okay, so then we're going to do multiplication. So we assume this one has length 1 and 2. Okay, so for I is greater or equal to 0 minus, so carry is equal to 0 because we're going to do addition will give us a carry. So the other variable name number 2 is greater or equal to 0, j minus. Okay, so this time we're going to do a single digit multiplication like this and this. So how we're going to do this, we're going to have a temp variable to store the value temporarily. So we're going to have a int temp result. So for this result, we're going to have some, we definitely need the digit of number 1 and digit of number 2. We're going to convert this to the integer because we're going to do integer operation. So number 2 jet, this just converted to the integer type. We're doing casting. So carry, and well, we're gonna do this as well. This is the previous I plus z. So let's say this part it will be I plus z plus 1 because right, and then we convert this to the integer type. So this time carry is equal to temporary result divided by 10. All right, so result is equal to the temporary result well, let's do this digit by digit. So result the I plus z plus 1 is equal to temp oops, yep. So and then we're going to do result okay. So we basically finalized the most important part of the multiplication, I believe. The only thing that we need to do now is to handle the 0, like if some of the, because we need initialize the result with 0, right? So this might cause the result being like this. So 0 0 0 0 0 5 0 5 6, right? So this is what we want. This is not what we want. We only want this 5 6 0 0 0 8 8, right? So let's do in this one. So we're gonna find the non-zero index equal to 0, and well, the result non-zero index is equal to 0, and we cannot go out of scape, right? So non-zero index is smaller or equal to, or maybe just smaller, otherwise it goes out of scope. So result dot size, the size of the string. If this happens, we're gonna do we're gonna increment the right. So and next, if non-zero index is equal to string, if we don't find it, nopes, right? I think it's nopes, and we do non-zero is equal to result dot size minus 1. Okay, and then we're doing a result we clear all of the 0, right? So 9 0. Okay, cool. I think that's all. We're gonna return the result finally. So we just do cout. Oops. We just do basic multiplication. 1 2 3 4 5 6. Oops. Oh. 4 5 6. Okay. Oops. Interesting. Give us a question mark. So well, I can't see any problem with our algorithm. So let's just check some. If we just going to see out something like this, we're going to see out the result. Test 100. Okay. This is not what we want. So we probably have trouble with the results digit. Let's have a look. So carry. Well, here. It's a type mismatch. We need to convert this to. Okay, let's try again. Yep, cool. So I think we've done this correctly. Just let me check again. Let's doing the test case. So 1 2 3 4 5 6 and 98. We go to the line 132 and 98. 1 2 3 4 5 6. We ring compile and run program. Well, 120986. Where's my calculator? I hope it's to store the value. No. So oops, we expect this value. Yep, exactly. Okay, so let's just do one more test for 0. So if I put a 0 here, I hope it will give us a 0. Please. Yep. Cool. Okay, so I think we can finalize this problem here.